I'm going through the history of our patent. It's been like about 3 years. So we have been adding to it and modifying the technology. Let me go through the team. I've been privileged to work with great colleagues here, Peter Vorobiev, Pat McDaniel, Said Sopan Ali Yassin, and Mahyar Purgasimi. Most of them are from UNMSOE, Mechanical Engineering and Nuclear Engineering departments, and one independent researcher. Initially, the work was supported on the fundamental topics through an LDRD by Idaho National Lab, and then later on, we got subcontracted by purchase order with Sandia National Lab and also a private sector that we were developing and helping them with a version of the solar power that was although out of the scope of our patent, but the funding helped us to develop the work. So here, the technology that I would like to talk about is focused on low air temperature as air Brayton cycle, that we would like to use it to avoid using water in the cooling in the secondary loop of reactors and power cycles. So while we would like to generate low carbon or zero carbon energy, at the same time, we would like to avoid using water as a coolant. Working on this technology helped us to develop milliscale and microscale different with different material candidates that for the first time have been used, these materials in the millichannels as a part of the secondary loop of a microreactor. And by microreactor, we are talking about less than 10 megawatt power. So I'll start with a little bit of a background here and motivation and go through the technology. So this is the energy consumption in the country. 2016, the numbers have not changed that much. Till now, 2021, the share of solar energy, unfortunately, is still pretty low, and the share of nuclear energy as the solely clean energy is still less than 9%. Now, our patent has an agenda to increase the share of solar energy, as our colleague was talking about the fact that solar energy by itself is not going to provide a constant level of power. Just by getting a cloudy sky, we may need to switch to other types of powers that would make some fatigue in the turbine and power cycles as well, by switching the power systems in the grid, as well as the fact that having a nuclear source of power, combining with solar sources of energy would have its own challenges. So our goal here is to increase the solar energy's share while we are investigating combined cycles with nuclear power sources. This is one part of our objective here. The other fact is, unfortunately, the largest consumers of fresh water in the US are thermal power plants. And one of the solutions to this would be dry cooling, or using cycles that would avoid using water, fresh water. And as you all well know, having access to salted water or seawater would cause a lot of problems and maintenance. So fresh water is still one of the solutions for cooling purposes of power plants. But at the same time, Palo Verde in Arizona now is dealing with serious issues because of shortage of water. So the next crisis, if we are hearing about water crisis, it's very true, and it's going to impact different elements of civilizations, mainly energy, and later on other fundamentals. But our focus is on the fact that how can we develop solar energy combined with nuclear, as well as not using fresh water. So mostly where we are heading to is because of our approach of using energy and burning energy. And of course, we need to support renewable energy sources from blue energy to solar energy. But here the approach is focused on combined cycle, making sure that we can avoid burning woods. So we started by working on solar chimney power plant. So this technology by itself is old, is based on natural convection and getting energy by irradiation to the air accumulated in the collector, so we can move the turbines and generate electricity. And there was a prototype in Spain in the 80s, and we focused on that to see if we can modify the technology and use that as a low temperature air Brayton cycle combined with other cycles. So we came up with a methodology for the first time that was the most accurate method to predict the thermal behavior of the solar plant. And then we also applied some computational analysis. Some of the works were published before, but we used the skills and the methodology to evaluate our patent. Our patent started by coming up with a new type of a collector as a double inlet collector to come up with atmospheric boundary condition to capture any atmospheric boundary condition, as well as applying the double inlet for any solar chimney power plants that are already built. We also modified our methodology and analytical work. I'm just talking about the technologies. Later on, I'll go through the results. The other part of the patent is about combined cycle and combining the modified version of the solar chimney power plant with any sustainable, consistent source of power, as an example, nuclear power plant or coal power plant. But here, since our focus is on low carbon, zero carbon energy, we have tried to come up with design parameters for the technology for a nuclear power plant in different scales. Speaking of scaling, while we were working on some components of the technology, we found out we need to focus on milliscale and microscale heat sinks for this patent. Therefore, we develop new designs of heat sinks, which I'll talk later on about that, and that's a key part of our patent. Using milliscales or millichannels or microchannels for dumping heat is not a new thing. However, applying a new design for the formation of introduction of heat flux to the coolant and using different coolants to come up with this technology is one of the novelty of our patent. Although always when we talk about millichannels and microchannel, we have the disadvantage of pressure drop. That's one of the parts that we have tried to overcome here. So about the applications, it's focused on low carbon, zero carbon energy, depending on the ratio of the carbon components. And we can use it in any cooling parts, applying in different scales of heat sinks, micro heat sinks and macro heat sinks. And based on the interest of Idaho National Lab, we will be using it also in fission batteries as a portable, a smaller modular reactor. However, it has different components with respect to the reactor with a smaller power scale that we can have it on a truck, or a soldier can carry that source of energy. But we need to have a cycle to dump the heat. Again, air Brayton cycle would be the best, depending on the work. Our focus is right now on natural convection. The market and the best customers on the government side would be DOE and DOD laboratories. And indeed, most of the agendas on dry cooling or waterless cooling and combined cycles, they are coming from the agencies, as well as energy stakeholders and subcontractors. Speaking of the results and proof of concept on the double inlet, we could overcome and increase the efficiency of the solar power plant up to 14%. We evaluated our work computationally and experimentally with the prototype. Computationally, we use computational fluid dynamics tools, modeling tools, and most of the steps we could verify and validate going through V&V skills and assessments. For the combined cycle also, we could overcome and increase the overall efficiency, thermal efficiency of the power plant. Speaking of an 800 megawatt pressurized water reactor, up to 4%. Working on larger scale reactors, we would go through different regulations of NRC. That is why we have changed our focus on the small modular reactors and miniature reactors in the language of Sandia. But theoretically and computationally, for the proof of concept, we have analyzed it when we have proved that the efficiency of the thermal power plant with the thermal efficiency would increase up to 4%. On the smaller scale and milli scale and micro scale heat sinks that would be used as a component in the cycle, we have developed several designs as technologies part of this patent to enhance heat transfer and cooling part. Mainly, we are using molten salt and air, avoiding any water. Although for the proof of concept, we use water because there are many publications about water. So we have a lot of data, exact solutions, but our focus in the patent is on molten salt and different material candidates and coating on the microchannel with different geometries. The ongoing work that we are working on is on the combined concentrated solar tower and a solar chimney power plant to have both technologies in the same body while we would avoid any fatigue and pressure drop. And because of that, we are focusing on a smaller scale reactor, specifically for the receiver of the concentrated solar tower. While we are talking now, just earlier this morning, I had a conversation with my colleague, Laura Sobol in Italy. We are trying to come up with a different version of this technology, applying milli channels in a fusion technology. While all I have been talking about mostly was focused on fission. So that's why Gyratron has one of the systems for fusion heat sources in Europe. We are trying to develop the cooling cycles, and we are trying to come up with different aspects of this to develop some works. As soon as the paperwork of this patent is done, we would submit our mainly focused proposal with Sandia on micro and milli channels applied in the cooling cycles of this combined reactor. I tried my best to not pass 10 minutes. I am available for your questions. Thank you.